So Maslab is a artificial vision-based contest, which means that each robot has on it a camera and some sensors, and they move around in this playing field autonomously. Their task is to collect balls that you see here up on the screen, and then based on a set of rules that we have up there, they get a number of points. Now, the robots are moving sort of completely under their own sort of design behavior. And at the end of 5 minutes, each robot will have, if they have ball in their possession, then they get 1 point. If they try to score into one of these goals, either red or yellow, and they succeed, if they score it into the right colored goal, so if a red ball goes into a red goal, then they get 6 points. If a yellow ball goes into a red goal, or vice versa, then they only get 3 points. If they fail to score, but the ball is within 12 inches or 1 foot of the goal, then they get 2 points. So that's all important. So they have 5 minutes. There are 2 runs. There's one run that's 5 minutes, and then 3 minutes where they'll have an opportunity to fix any emergency problems in the second run. And then from the 2 rounds that happened, we take their maximum score. So because they're using cameras, it is extremely important that you guys not use any flash photography. Sort of like to take a moment again before starting. Our sponsors are Sun Microsystems, Lockheed Martin, 2 Sigma. Analog Devices provided gyroscopes that a lot of the teams have used for sort of determining the angular rotation of their robots, as well as Corsix, electrical engineering. Okay, so would the spokesman for Team 1 please come up? Okay, so.
Oh, my name is Mason. I'm with Team 1.
Okay, cool. Okay, so it's worth saying, so during the course of the month, the teams here have only had the month of IAP, around 20-25 days to sort of design and build their robots, which is a pretty monumental sort of mechanical and electrical and software task. Team 1 actually won the first, we called it the Director's Challenge, where they had to drive down in a straight line, basically, which for any of you who are electrical engineers is a surprisingly complicated feedback problem, or sort of, if you're not used to that sort of thing. Now, Mason, what's the most interesting thing about your robot's design?
I think what's interesting about our robot is we made a lot of decisions about, we use omni-drive, so the robot can translate in any direction. We have kind of a unique scoring mechanism. You see a lot of the robots have rubber band wheels, and we have a completely passive scoring mechanism where a robot just drives over balls and closes the gate. I guess we're just going to run the robot. You can see for yourself.
Ready? 1, 2, 3, start.
Okay, so what is your? How did you choose to design your robot's behavior in terms of the scoring field? I see that your robot collected 1 red ball.
So the robot operates in a pretty simple state machine. So right now it's trying to scan the field. It's got 4 basic states where it can either wander around the field and try to explore new areas, which it's doing right now, and it can also scan 360 degrees around the robot, and there's also capturing the ball and scoring the ball. So basically, depending on how each state reads its sensors and what it sees things, it'll transition to the next one. Oh, and also right now our bot client is just printing out what the camera see, and it marks what it thinks is a ball and what it thinks is a goal. But the problem is that it actually lags behind quite a bit, so we're seeing the past right now.
So the audience may not hear it, but the robot is actually talking about what it's doing, which is fairly unusual for computers. Computers usually don't talk. Can you sort of describe sort of what's going on with your robot?
So how it's talking? Sure. So right now it speaks what state it's in. So this is capturing when it's capturing a ball, and it says, I see a yellow ball when it sees a yellow ball. And we do that with just a basic Java library that I found. It's a free pure Java implementation of a text-to-speech library. So we just tell it what to say, and it says it and have a Stephen Hawking type voice.
So your robot's collected a lot of balls. What is your strategy for scoring?
So the robot right now knows it has a few balls. It sees a goal right now. It's going to line in position in front of the goal, and it's going to try to correct a few times until it can see the goal completely, and repeat this mantra that it has. Oh wow, that's interesting. Okay, but the point is that it'll see a goal and then line in front of it, and then open its gate and kind of ram the goal with the balls kind of rolling out, and then close the gate and then double tap it so that each time is pushing. Hopefully it's kind of unstuck itself on that.
You can do it.
It takes a while sometimes, so hopefully this is
There are a lot of balls in your robot. It's interesting. In previous years, I've seen robots that have been extremely effective at collecting balls on the playing field. This actually happened, I think, my freshman year 4 years ago. There was a team from Random that had collected so many balls that their robot had sort of ended up propping itself up on one of the balls and then wasn't able to move. It collected almost all the balls on the playing field. So currently, your robot.
The thing is, it's moving slightly, so it's not stalling. It's not stalling having the wall there. It should stall out eventually.
Now you don't have any bump sensors. Now, how is your robot when it sort of runs into a wall? How is it? What sort of strategy do you have for escaping from the wall when you run into an obstacle?
So we have a mouse, an optional mouse mounted on the bottom of the robot, which kind of tracks how far it's been moving over time. So if it hasn't moved a certain amount of distance in the past at some time, then they'll treat that as a stall and kind of back away and arc away from where it's stalled.
Okay, so time's over. The arbiter is going to see how many balls have been collected and then determine the score. And then Team 1 will have an opportunity to check up on their robot, and then we're going to have a second run with Team 1.
The measurement one.
Mason, the webcam's off and the key's on and it's about 30 seconds early.
In the interim period, we're going to be playing a short 3-minute video, sort of a short interview about the design decisions that Team 1 made and some of their problems during the IIP. It's going to start right now. So Team 1 managed to get 4 balls on the porch, and I think I said 4 possessions on the porch. Oh, sorry, 4 possessions. session and then one on the porch. Currently, I think the robot lost power to the camera, and so they're replacing the battery on the laptop, and so they will be back in play in a minute or so.